Hello and welcome to lesson 5.2 on congruent triangles. Today's goals are going to be to use congruence criterion of corresponding congruent parts of triangles to solve problems, and to use the third angles theorem and the properties of triangle congruence to solve problems and to prove relationships in geometric figures. Okay, basically, easier version of that is just to say that we're going to try to prove whether or not certain shapes are the same as other ones. Now, this is something that is very easy for us to do visually. Just to look at two things and say, is that the same shape or not, is not a very hard thing to do. But mathematically, to precisely say why they are the same or why they are not the same is kind of the skill that we're going to go over today. Okay, so let's read this learn section together. The principle of superposition states that two figures are congruent if and only if there is a rigid motion or series of rigid motions that maps one figure exactly onto the other. Recall that congruent figures have exactly the same shape and size. Okay, so like let's say I have two chopsticks. If I can get one to the other position in a rigid motion, or I have to maybe turn it. Maybe there's a composition of rigid motions to get me there. Maybe I need to flip it over or something. So I rotate and then I go over. So those would be rigid motions. Okay, a non-rigid motion would be bending, stretching, things like that. So we can't do that. We're not allowed to stretch our objects. We're not allowed to bend them. But if we just move them around, if you can move one object and get it to the other one, then they are congruent. Okay, so in two congruent polygons, all the parts of one polygon are congruent to the corresponding parts or matching parts of the other polygon. What are all the parts of a polygon? Well, there's the sides, like the length of the sides, and then there's the angles. So like if you've got a polygon and it's got some sides here and they meet at a vertex, for it to be congruent with another polygon, you need to have the same lengths of the sides and they need to come together at the same angle. They can't come together at a different angle, right? It needs to be the same angle. So two triangles are congruent if and only if their corresponding parts are congruent. That's kind of our main idea today. And I like this part. It says, for triangles, we say corresponding parts of congruent triangles are congruent, or Cpctc. I have never heard anyone in my life say Cpctc, but evidently some we out there, some group of people, like to say that corresponding parts of congruent triangles are congruent. And they say it so often that they're forced into this little acronym down here, Cpctc. They just say that to one another, I guess. All right, well, maybe we'll start saying that to each other and reminding ourselves that corresponding parts of congruent triangles are congruent. Cpctc. Maybe we'll see that in the next example.